Hello, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So today we have a medium. It is called count substrings containing every vowel and k consonants. 2. So it is like some follow up. The question is actually pretty short. So you're given a string word and an integer k, right? So what length do we have? Right. So the word is like 200k. Only lowercase English letters, and k is word dot length -5. For some reason, it is -5. Let's find out why. Uh, Total number of substrings. So substrings is contiguous again. Of word that contain every vowel. Right. So it has to contain every vowel. That's why. That's why the -5 there, at least once, and exactly k consonants. Right. So we can right. So what we can do is we first of all we definitely need a way to check whether we have like all the so yeah, so what I'm thinking is yeah, so we are definitely like checking like some portion of the string, right? So like let's say for like a IOQ, let's turn it to U for now. So we're definitely like checking a part of the substring. How long does this substring have to be? Well, if k is equal to 1, like example 1, right? Example 1, k is equal to 1. That means our substring has to be it has to be at least 6 long, because well, like you need 5, like you need AIOU and exactly like one more like non-AIOUs. Yeah, which is yeah, so this problem, yeah, I'm just making some observations right now because there isn't like a really obvious solution yet that I can see. Um so yeah, let's think about it a bit harder, I guess. So we have so yeah, first of all, we definitely need a way to check whether like our substring has A E I O U, right? So um hmm I guess like one way we can do is we can check, like we can keep count of how many AIOUs we are seeing in our substring. So like in our case, we'll definitely start from the left, right? So we'll just count like that. So AIOU, and then like we can also like have the number of the number of vowels um in our current substring. And so let's say like we get a length p kind of substring, and we have like we have two A's and then like one of each. Like for the other ones, then that means like we have like we're gonna have 6 vowels. So we just have to check whether 6 minus p equals k exactly. If it is equal to k, we can just well we can add one to our string. But if at any point our number of consonants like if at any point we have too many consonants, that means we can't keep expanding that way, right? So we have to like retract from here, but we also like have to keep count of like the number of vowels we have. So like let's say like we retracted here, we have to like reduce that by 1, and then of course we check whether we still have too many consonants. uh if we do, we have to like keep retracting. So yeah, it's kind of like a 2-pointer, I guess. But let's just code it out. I'm pretty sure that's how you do this. Um Yeah, maybe we can think of example 3 a bit. So we have IALU. So we want one consonant. So this would work. But then when we add Q in, we have to keep shifting like the left bound until we only have like one more consonant left. So I guess we can also like store the number of consonants, consonants. Yeah, but actually we can just calculate that on the run. Yeah, so like at the end, like the left and right pointer is gonna meet at the same place. Wait, actually k can be 0 as well. Huh. Right, I guess like in this case, like right, like left would be like here, right would be there. So you do have like one thing. Like if it is 0, then like left and right can be like stuck together. And well, if they're stuck together, like we guarantee that it wouldn't be larger than like our number of consonants wouldn't be larger than k. So we just keep looking like on that side. Oh wait, but yeah, in this case we have this, and then like of course we look at that, and then oh we find another one, and then we look at this. We have to retract one, so we get rid of that. But then like we can see that this still works, and then like of course we see that, and then we have to like shift all the way. So we have to shift to here, and then okay, there's like nothing left there. Yeah, so I think the algorithm works, but let's just test it out honestly. So number of vowels is going to be 0 for something in range 5 because we have 5 vowels. Yeah, I don't even need I don't even think we need a sum. We can just keep like getting the sum of this array like for that. And then of course we need a left pointer and a right pointer. So we just do 0 0, and our thing should be inclusive this time, right? Okay, let's think about whether it should be inclusive. Yeah, so our right bound could be exclusive, but would that make it easier actually? So it starts at 0. I guess this is exclusive because like when we say this, that means like both L and R are like on that side, so we don't actually have anything. And yeah, I think exclusive is better because we can just do R minus L we can get the length of the like the number of the length of the array. So we just have to check so while I guess while let's think about this. So we can just set it as while true right now. But then we definitely need to like think about what is the correct like while condition up here. So we have yeah. So let's just think about this case. This is a good case to think about for this. So so yeah, we want to find out the number of consonants. I guess I'll just keep count of. So total vowels and total consonants. So so if R minus L, we can just do if total consonants is larger than K. That means we have to contract our string. So we will shift R up, and we're guaranteed that they wouldn't cross. Yeah. And so also what do we have to do here? We have to so this is like if we reach this here, right? We have to check like where R. Wait, wait, no, it's not out. Is we have to shift the left bound. So, but we have to check the original like L value, if it is a vowel or not. So we'll just do vowels, A I O U. So if in vowel, so if the word is a vowel, we want to we probably need a map as well, right? Let's think about what is a nice way to code this out. We just create a map. How map? So A is going to be 0. E is going to be 1. So this is the index for the number of vowels array. I'm sure there are some nicer ways than creating our own map here, but let's just do that for now. So number of vowels, vowel map, and then our word. We just want to decrement it, and then we can increment that. Oh wait, actually, otherwise, we don't really care about. We don't really care about the like what consonant it is, so we can just do a -1 there. Yeah. So otherwise, so that means the number of consonants is smaller. Well, we can just do elif, I guess. So elif. Oh wait. So this is too many consonants. Make some comment. This question is pretty chunky. So and then we have no vowels. Not enough vowels. So we just have to do for num in num vowels. If num is equal to 0 for any of them, we want to increase our R. Oh, maybe. Yeah, because R is always bigger, maybe here we can just do if R is smaller than the length of word, because like once it crosses the length of word. Wait, but we are doing it exclusive. Yeah, so maybe we need that. We're doing that exclusive. Yeah, so if number is 0, we want to add. Yeah, okay. I think that should be fine. But then we actually need to continue on each of these cases, cause like we have finished with that already. If we do have enough number of vowels, we can just continue. We like if any of them are too small, we can't actually continue. We want to add the next number in, and so if our right bound is 0, and when we increment it, that means it is going to include whatever like the index R contains, I think. Yeah. So again, we just copy this logic here. Oh wow. So if word R in vowels, we can just increment the vowels counts. Otherwise it is a consonant, so we want to add that instead. So we have r plus 1 here, and then we continue. Yeah, we want to continue. Wait, but then we have for numbing vowels. Oh, we probably need a flag then. Has all vowels. Set as true for now, and then so you have done the the adding one number thing here. We also want to set has all vowels equal to false, and then we want to break. Oops. And so if not has all vowels, that means we have changed our bound already. So we just want to continue and go to the next thing. The last thing is going to be whether we actually have enough consonants. So if total cons is actually smaller than k, well, we want to keep adding characters to the right. So just do the same logic here, which I don't know why it's so messed up like this, but yeah, we just need to do that as well. Yeah, so we add more characters. So else, well, actually this else, because we have covered total cons, like total consonant is larger, total consonant is smaller. I guess it is safer to just do this as well. So total cons, if it is exactly equal to k, that means we can have a num wait, what can we have? We can have the number we can just like count of substring. So we can increment count of substring here, and then at the end we can just return count of substring. Well, there's one thing that I'm not confident about. That would be this part here, because here, so like when r becomes the length of the word, it can still run. But would it ever run this? It probably will, right? So so I guess we might have to check that, maybe. Like we have to check whether wait, actually, because r is exclusive, if it is equal to the length of words, so like when our r is here, right? Because it is exclusive, it should still check like all of them. But then the thing is, it doesn't necessarily run into this case, right? So like let's say for our string here, like substring here, well, it should keep contracting until like L is here, right? And R is here. So we have this here. But then that means we are going to run into that means we are going to run into the has all vowels thing. But then we don't actually want it to add another like word R. Like we don't want it to do this, because that's going to cause an error. It is out of bounds. So maybe we have to do, if R is not equal to to the length of word, and so that should be able to check. And then, well, if it adds one there, that's totally fine. We don't really care about it. Yeah, we don't really care if it adds another one, because like we reached the end already. It's gonna go here, break, and then it's gonna go back here. It becomes like, r plus one. Ah, yes. What about here though? So it has all the consonants. So is there a case where it has like A, I, O, U, but then you want to actually keep looking? Yeah, actually, is it possible? Yeah, maybe we want to. Maybe we want to just make sure that doesn't fall into any case as well. Oh, actually, one more thing. If this is correct, do we contract or do we expand? That's another question as well. Cause like technically, wait, yeah, technically we can have like you know uh a E I O U Q, something like that, right? And if we are looking at this string, um if we are looking at this string, like, should we look at this as well? Or do we add another and see, if we can form one more here? Yeah, cause like right now we can have this string, we can have this obviously, and we can also have this. So we have to, yeah, we actually have like quite a lot to check then, right? Well, but our original one is going to be landing on this first. Um. Oh wait, actually, this also works as well. Yeah, and then this works. So if you expand first, you're gonna miss out on this case. Um, but if you contract, well, if you expand, you're gonna miss out on this case. But if you like sidestep that way, you're gonna miss out on this case. So this is another like really annoying thing we have to deal with actually. Um, I guess we can do like, oh, um, okay, if we keep adding, hmm, if we, okay, if we choose to expand, so we're starting with this. We're starting with this case. If we are going to expand, I think we have to check like at which point, like the AIUs are like no no longer like all non-zeros. So maybe we just like we have a temp and we just like loop through and we check like at which point um yeah at which point like it runs out of characters, I guess. Um yeah, but then we also have this to deal with, like, wait, so so if for the starting case we can also account for this case, so we've gotten these two done, and then we expand. So we expand, we are going to find that this works, and then we do the same contracting thing. Yeah, the thing is, with the time complexity be like well over if we do that? That's my worry. Huh. Yeah, I think like on paper. So like, let's say you have like a lot of A's, and then A I O U, and you have like a Q here, and then you have like a lot of A's on the other side as well. That means like when you get to this string, you have to check all of these. Um, well, until you get to this point. Yeah, you have to check all of that until you get to that point. And then when you get to here, because you're not retracting, you have to check all of these again. Yeah, so the time complexity would be actually too slow, I think. Hmm. Yeah, we have to think about some ways to counter that. So what about we do the last A we see? So like we store the index of the last A we see, we store the index of the last E we see, and so on. So like we can see that the last ones we have seen here. But what if we have like another, you know, consonant in there? Uh like let's say k is equal to 2 and we actually do get this string here. I guess we can store the index of the last consonant as well. So last consonant, we can store that as well. Um, because k is equal to 2, we know that like this string we have that. Um, so we can just maybe get the minimum of, you know, like the last occurrence of each of the thing. Um, so we want to we want to get up to here, right? And like anything before is like either a duplicated vowel. Yeah, I think that will work. I think that will work. I think that will work. Uh, yeah. This question is definitely not a medium. This is pretty difficult, unless I'm like missing something very obvious. So total vowels. So and do the last scene array. Uh, last scene for vowels. Just do that. Oh, we want the minimum, right? Yeah, but it doesn't really matter because when we actually get to that case here, when we actually get to here, we can see like where like we can be sure that we have seen all the files already. But what about last seen uh consonants? Can we set it as -1? So the only case we won't see one is if k is equal to 0. Yeah, so maybe this one we do have to set it as infinity for now. Yeah, just to not mess up the k equals 0 case. So yeah, we have to go here. Oh, but then we have the -1 thing. Damn. We have the -1 thing. What if we store it in a double-ended queue for each of these? And then like when we remove one thing, we can just remove the first one because like when we're removing from the left to right. Yeah, would that work better? Actually, honestly, maybe that'll work better. Um, yeah. So let's have a double-ended queue for all of these. So from collections, import double-ended queue. Last scene. We also have a double-ended queue, I guess. So when we have to get rid of a vowel, we can just do last scene vowels. You need the file map, of course. File map, and then we just do pop left. So you get rid of the leftmost one for this vowel here. And then for this case, we have to get rid of last scene consonant. So we have to get rid of. Yeah, we also have to get rid of the the leftmost thing. And let's see for this case. So we are adding a vowel. So last seen vowel. Okay, we have vowel map. Well, we can append word R because that's the word we are adding. So we can just append that. Otherwise, we have last seen consonant. Append. We can also append that. Wait, we are appending the index, right? Yeah, we are appending the index. We're not appending the actual word. Yeah. So it's just R actually. Those pop lefts wouldn't matter. So if it is smaller, we also want to add more stuff in. So you just copy this over. And then for the else case, of course, it's just going to be this. Yeah, so this is the place where we have to check. So, well, actually, if total consonant is equal to k, so if that is 0, so this is like for this case here, right? We can't get the last item for. Yeah, so I guess like we have to consider the edge case of k equal to 0. Yeah, and then you want to. Are we expanding? Yeah, let's expand because like we are doing the contracting when we're calculating this. So if k is equal to 0, so for this case we're not gonna get any consonants. So we should just get the max of yeah, when you just do array -1 for array in just do dq maybe. Yeah, dq -1 for each of them. Oh wait, we want the we actually want the minimum. Yeah. So in last seen vowels, so we have that. Yeah, so last seen vowels is basically like 5 double-ended Q, right? And we want the last item because that's the last time they are seen. So we can just do wait, but so let's say we do find like the place. Let's just do this a. Yeah, it's just another like off by one kind of stuff that we have to figure out. So when we get here, we're going to finally have a valid string. The minimum is going to be 2. I think we check with the left bound, right? So our left is going to be 0 in this case. And yeah, so 2 minus 0 should give us the number of characters like until we have the smallest like possible valid substring. So if there are 2 characters, that means we have like 3 ways, right? So we can include all of them, we can include only up to here, and we can include there. So we have 3 ways. So what we can do is we can check the minimum minus L plus 1, and then we add that. I'm positive this is correct, although this does not look too nice, I have to say that. And then we have this, of course. We also want to check the last seen consonant. I think you can do this. Like you have maybe we'll turn it into an array maybe. Yeah, and then we get the count. Oh no. Out of range. Which case? Oh, for this case, it is out of range. Let's think about this. So we have count of substring. And then minimum. So it must be this thing here, right? Wait. Oh. I forgot that. That's why. Oh, okay. So it doesn't actually allow that. I guess we can just get the minimum of that. So that'll be a number, and then that'll also be a number. That should work, right? I think. Oh, we're failing that case. And we actually get a lot. So let's see why. So when we get here, it should check. When we get here, it should retract like this. Maybe our consonant count is off. Well, actually, yeah, it should break out here if we haven't seen all the vowels. I guess we can print the range, and we can also print the number of vowels, maybe. Yeah, so that would be this case. So that looks good. So 0.5 and then 0.6. Wait, didn't stop at 0.6. Huh. That is a bit confusing. Because it just keeps going. Did I forget to... Or maybe I increment the wrong thing. Wait, but when I have our... Oh, I forgot to actually like add the next character in. I think that's why. Yeah, so we have to do, let's see, this thing here. So yeah, if R is not that, what are vowels? So we want to add, if it is a vowel, if it is a consonant, we have to like increase that as well. I think that's why it is wrong. Oh. Hey, it's probably like here then. Yeah, of course. Okay. I'm not that confident. I think there will be like some edge cases that we fall for. Yeah. Well, we're passing a lot of cases. Let's see like what is the issue here. So we have k equals 2. Our output is actually 4 in this case. So we look at this here. So that's gonna be the so A E R U S everything, and then it has 2 consonants. So this is gonna be the first place we stop at. We're gonna check the last index. So that should be I think. But when we get here, so when we have the whole thing, like because we're adding, right? We're actually adding another I. Right, maybe our... Oh, I see. We are getting the last seen files right now, but so like that means we are actually like getting this, but we actually want the second last. The reason we want second last is, well, if we set the minimum here, the smallest valid string is actually just going to be this, but we actually want 2 consonants. So if we go down here, this case, if we go down, this case here, I think we actually want minus k. That should be more correct. yeah, and like when we get past this case, we are guaranteed that like the double-ended queue for lasting consonant is going to have at least like k elements. Oh, it's going to actually have exactly k elements. Wait, if it has exactly k elements, we can just check the first thing, right? Yeah, we can just check the first thing. Okay. So let's see. Nice. Wow, this question is. Wait, is it actually a medium? This question. It is. But the acceptance rate is like really low. Um, yeah, very tough question, I think. Well, uh, maybe it's not like really really hard, but then like you have a lot of cases to deal with. I think for this question, like you need a data structure for storing the like for the AR use. You need to see through that. Well, like if you have something like like this case here, and like if you just keep checking that every time, it's gonna be too slow, or like if you just naively shift like either L or R, like as we have seen, like in this case, you're gonna be missing some stuff. So I guess that's why the acceptance rate is so low. Um, yeah, but like seeing through all the different edge cases is definitely very difficult for this problem. Yeah, so have a tough problem today. Thanks for watching, and I'll see you tomorrow. Bye.